Hi there. So another common use of proportions is to do unit conversions. And doing unit conversions is a very important part of math and science. And just to illustrate some of the problems that people have with unit conversions, there's a famous story in our history is in the early 2000s before the Odyssey rovers to Mars, there was a rover that was planned to land on Mars. And so that rover then approached Mars, and then it approached and it was supposed to land very slowly and land nice and smoothly on Mars. But what ended up happening is that instead it exploded whenever it hit the ground. And so there were all these billions of dollars wasted on trying to get that thing to land on Mars. And what ended up happening is that part of the system was designed in the U.S., but part of the system was devised in the UK, and people didn't check that they were converting units correctly between the English and the metric system. So that's a very extreme example of the importance of doing proper unit conversions, but there's lots of other more basic ones. And the thing is most people feel like at least a lot of people feel like they can do unit conversions by either multiplying or dividing by given numbers. The problem is, and you got to take my word for it, based on the sheer number of students that I've seen over the years, they just often get things incorrect. So what we're going to do is show a systematic way to do this. And that way, hopefully, you can avoid the very common types of errors that I often see. Okay, so we're going to look at a basic example that you could probably do without this technique, but to illustrate the technique. Okay, and so what we want to do is we want to convert 600 inches into feet. All right, and so we've measured some length in inches. It came out to be 600. But we know that if we convert it to feet, that number will be much smaller and easier to understand. And so we want to convert that into feet. All right, now the key thing here is that 12 inches is equal to 1 foot. Okay, like that. So, and like I say, a lot of you know how to do this problem, and you might be rolling your eyes at me, but I promise there's two things. A, we'll see a lot more complicated problems where it's not this obvious, and B, like I say, it's just very common for someone to multiply on this problem instead of correctly divide, which is what some of you might be thinking. So what we want to do is just come up with a systematic way to make sure that we always get things correct. Okay, now whenever we see this this is called a conversion factor. It tells us how to convert between inches and feet. But another way to word that is that there's 12 inches for every foot. Okay, for every 1 foot. All right, like that. And so if from our last video, we can recognize that as a ratio. All right, and so we could write this as a ratio, 12 inches to 1 foot. Okay, like that. And then remember from the last video, we talked about we could write any ratio as any ratio as a fraction. And so we have 12 inches over 1 foot. So the basic form of our conversion is we have inches in the numerator and feet in the denominator. Okay, and so we can take what we're given. We're given the 12 over the 1 is equal to, what else are we given? We're given 600 inches. All right, so where do the inches go in these fractions? They go in the top, I'm sorry. They go in the top, and we're trying to find the number of feet, and that's what's in the denominator. So again, just like with the last video, we could use X, or if you want to use letters that'll help you remember what you're actually trying to find, you could use F for feet, like that. Okay, and so there, I don't know what I just did there, but sorry about that. So now we have a proportion. Okay, and so this is a proportion that we can now solve. All right, and so again, hopefully you're getting used to this where you don't need to do this every time or need to see this every time, but there's our two cross products, and so we can equate the cross products. And so for my first one in red, I have 12 times F is equal to 1 times 600. That's 600. Okay, and so now to isolate F, I would divide by 12, that, and if I do that, I get 50. All right, like that. And so what is that? That 600 inches is 50 feet, like that. Okay. Now, one thing here, in this problem, the problem came out as an even whole number. I rigged that for our first example. But very often these will come out as fractions. Especially in the English system, it seems like we use mixed fractions a lot, but like there's only really special cases. So what I'm going to tell us to do whenever our answer comes out as a fraction, this will be our first time where we really do this. We're going to use the decimal form, and we're going to round it to 2 decimal places. So we'll talk about that. Well, we'll talk about that on the next slide. All right, and so here's a different problem here. This is a conversion between the English and the metric system. So inches, hopefully you're a bit familiar with. cm is the abbreviation for centimeters, so it's close to the equivalent of an inch in the metric system, but it's a bit smaller. Okay, and so what this problem's saying, and this is a fact, that 1 inch does equal 2.54 centimeters. All right, and so say I want to know how many inches is 8 centimeters. Okay, and there's, with unit conversions, there's actually several ways to do them. I don't want to tell you absolutely just to do things my way, but like I said on the last slide, A, there are much more complicated problems where it's easy to get lost in them, and B, just people make mistakes so often in doing, dividing when they should be multiplying or vice versa. So this is just a nice way to let the math present itself through algebra. Okay, and so the idea here is that we're given 1 inch is equal to 2.54 centimeters. Okay, and so we could write that also as a ratio, like that, and then we could write that as a fraction, 1 inch over 2.54 centimeters. Okay, and so the basic form of our ratio is inches over centimeters, and so in terms of what we're given, that's what I have written above, that 1 inch is equivalent to 2.54 centimeters. We don't need the units in here now, though. The reason we don't need the units is we have them denoted over here. Okay, and so then what are we given? We're given 8 centimeters, and the most common place for people to make mistakes whenever they're using ratios is not to line things up correctly. So notice if I put the 8 right here, the 8 is in the inches position, okay? But this is 8 centimeters, so it needs to go in the centimeters position, all right? And so I have that in the wrong place. The 8 would go down here in the denominator, okay? And then I'm trying to find the inches. So here you might want to use X, here, and I'll explain why. If you wanted to use a descriptive letter, you might use I. And you can use it if you write your I's clearly, but a lot of people write I's where they also end up looking kind of like ones, so they'll get a little bit lost with that. All right? And sometimes I fall into that regime, I'll be honest with you. And so I usually don't use I as a letter. I'll go ahead and use X. Okay, but you don't have to. You could use I if it helps you. Okay, so now I'm not gonna draw out the cross product. See if you see the cross products there. And so my first cross product is the 1 and the 8. All right, 1 times 8 is 8. And then my second cross product is 2.54 times X. Or remember, if I'm multiplying a number times a variable, I don't have to write the times in between them. But you can. Okay, and so now to isolate X, I just divide by its coefficient, so 2.54, like that. Okay, now the thing is, especially now, our conversion factor has a decimal in it, and so to answer in the form of the problem kind of implies that we would answer in decimal form anyway. But like I say, with this assignment, I'm going to encourage you to do that. Okay, this is a very interesting number here. So whenever I type this on, so x is 8 divided by 2.54. Okay, now what I'm going to tell you is I'm going to tell you to round it to 2 decimal places. Okay, so we haven't talked about rounding much. Hopefully you're familiar with it. All right. Um, so whenever I type this in on my calculator, this is what I get: 3.1496 063. It's on my phone's calculator. All right, like that. But in the directions, I'll tell you to round to 2 decimal places. Okay, and so here's the decimal. So these are the places, and so here's the second decimal place. And so remember, the idea of rounding is you look at the number to one place to the right of it. You ignore everything else. Okay, all you do is look at the one digit to the right of it. If this number is 5 or above, we increase this by 1. If this number is 4 or below, then I leave it as that number right there. So what would we get in this case? We would get, now leave a little bit of space if you're taking notes, but that's 3.15. Now, what are we finding here? We're finding x. That's a number of inches. And so, at the very least in your answers, make sure to include your units like that. Now, there's one other subtle point here, is that notice that these two numbers aren't exactly the same. Okay, 3.149603 is slightly different than 3.15. So in cases in math when we want to emphasize that this is what we're writing is a rounded version, we'll often put a squiggly equals there. And if I were going to circle this in my work, I would circle these two right here. Okay, this right here, this is the exact answer. It has no rounding in it at all. You might be saying this isn't rounded either, but your calculator actually rounds this digit right here, the last digit that it can display. So this is the best form of an exact answer that we can get, but then we'll round it to 2 decimal places, and we usually say that's approximately equal. That's the way that symbol right there means, approximately. Okay, so what I want to show you are some typical conversion factors. Some of them you might be familiar with, some of them you may not have heard of, but we'll need to use these to do homework and practice with this. So here's what we'll be looking at. You'll see this in your homework. It'll be a table to help us. So these are just some common conversions between units. All right. Now, if you're unaware, there's 2 basic sets of units. There's what are called English units. That's like feet and pounds and ounces and quarts and so on like that. And then there's metric units. So those are meters, grams, and liters. And then there's some breakdowns of them, like cm is centimeters, mg is milligrams, etc., etc. Now, one thing you can do too, even if you don't understand these abbreviations, you can look them up. Okay, do a search on the internet for what they represent. But you can just take them as being some kind of given thing, and as long as you keep your ratios lined up, then things will work out fine for you. Now, sometimes, like with that last example, we want to convert between these two systems, and so that's what this table right here gives you. All right, so a ton is a English unit of weight. Kilogram is a metric unit of weight. So this right here tells you how to convert between tons and kilograms. So we'll use this table to do various conversions. Okay, and so I'll bring this back up in just a moment. I'm just going to set it over here for a moment. Okay, so yeah, let's look at some examples that we'll see in the homework. So the directions say use the table, it's referring to this table, to convert from the given unit to the specified unit. Okay, so this first problem says 12,000 FT to MI. Okay, and the reason I'm saying the letters is some of you may not be aware of this. This is the abbreviation for feet. This is the abbreviation for miles. But even if you're not aware, just take this as kind of a unit, FT, and this is unit MI, okay? And you can still do the problem. That's the nice thing about unit conversions. You can actually do unit conversions without having any idea what the things represent, as long as you have a conversion factor. So let's look here. We're looking on this table that somehow connects feet to miles or FT to MI. So you got to look around. Now you do have a clue. This is FT, so it is an English unit. So it's either here, or in here. It won't be in here because it's not a metric unit. Okay? And so you just look around here. Here's something that has feet, but it's to inches or INs. Here's another thing that has feet, but it's to yards or YD. But if we look right here, here we have FT and here we have MI, or you folks that know, here we have feet and here we have miles. So that's our conversion factor that we want to use right there, is that 5,280 feet is equal to 1 mile. Okay, so that's what we want to take as our given for now, and so we're given 5,280 feet is equal to 1 mile, like that. And so we want to write that as a ratio or as a fraction, and we could write the fraction as feet to miles, like that. And so in terms of what we're given 5,280 over 1 is equal to, now we're given that 12,000 right here. What is that though? That's feet. Where are feet in my fraction? They're in my numerator. Okay, so I want to put that 12,000 in the numerator, and then we're trying to find the number of miles. And so if you wanted to use a descriptive letter, you could use M, or like I keep saying, you could also just use X. All right, now we have a proportion that we can solve, and so there's our first cross product. Here's our second cross product. The nice thing about conversion factors is that there is usually a 1 in them, so you can take advantage of that too. All right, but anyway, if I equate my cross products, I have 5,280 times M is equal to 12,000 times 1, which is just 12,000, and then I go and divide. Okay, and so here they cancel, so I just have M on the left side, and then I have 12,000 divided by 5,280. All right, and like I say, in this assignment, I'll let you round, so you don't have to give the mixed versions with that. All right, and so on my calculator, it gives me 2.27272727. Okay, but like I say, I'll tell you to round to 2 decimal places. So here's the second decimal place. I look 1 digit to the right. That's smaller than 5, so I'm not going to round at all. And so I'd say M is about 2.27. Now, what are we talking about here? Our variable was down in the numerators. Those were miles, or the MIs, like I keep saying, if you don't know what they are. All right, and so there would be our answer. Okay, like that. Okay, and so let's say I have 12, I'll say kg for now. That's the abbreviation to kilograms. And say I wanted to convert that to lbs. Those are pounds if you don't know that abbreviation. Okay, so the key thing is I need to go from kilograms to pounds, or if you don't, like I say, if you don't know them, it still won't hurt you, the kgs to the lbs's. All right, and so we just look at our table here. Oops, my writing's getting in the way, isn't it? I didn't know that would happen. So let's look through this table here. We need something that connects the kgs to the lbs. All right, if you look through carefully here, there's no kgs in this one. Kg is a metric unit. Okay, and see, if you know more, you can shorten the process of looking. This is a metric unit. This is an English unit. So we're actually going to be down at the bottom table. But for you folks that aren't familiar, you just keep looking through here. Here's something that has kgs, but it doesn't go to the lbs. All right, and so we won't use that table either. So then we just keep looking. All right, and if you look long enough, you'll see right here that we have this conversion. Interestingly, notice that, let me zoom that in a little bit, but interestingly, if you look at that carefully here, there's an approximately equal to there. A lot of conversions going between the metric and the English system. require many, many decimal places to say what that conversion factor actually is. But we have that one, and whenever you see this on your table, just take that as an equal sign. Okay, so we have 1 kilogram is 2.205 pounds. All right, and so we can take that as our given. So we have that 1 kilogram is equal to 2.205 pounds, or lbs. Like I keep saying, if you're not familiar with those things, it won't kill you. All right, and so the key thing is here, so we can set up our proportions as kilograms to pounds or kgs to lbs. All right, and what are we given? We're given that there's 1 kilogram per 2.205 kilograms equals to, and now we're also given this 12 kilograms right here. And so where does that go? The kilograms are in the numerator there, so that'll be 12. And then L is kind of like I. My L's look like ones. I could use a capital L, but I'm just going to call it X right here. Okay? And so there I have a proportion, so I can equate the cross products. My first cross product is 1 times X. 1 times X is just equal to X, like that. And then my second cross product is 2.205 times 12. And so I have 2.205 times 12. Okay, and so I want to go and multiply those. And so I've got 2.205 times 12. All right, this one comes out to 2 decimal places. We got lucky there. And so we got 26.46. And what is that? Those are pounds. Okay, well, how do I know it's pounds? I just remembered what I would ask, what question I asked. But if you ever forget, just look where your variable is in your solving. Hopefully you've written this to remind you. So X is in the denominator. So it's telling you that X is a number of pounds. And so there's my answer right there. And so you can see, some of these problems, I know some of you probably looked at them and said, why are we going through this long process? I know to do this. You just got to trust me. And I've done it before, too. Just trying to go too quick, and I either multiply when I should divide or vice versa. So it's a very common thing for our brains to do because our brains just try to go too fast for us sometimes. And so this is a nice process just to make sure. And see, the thing is, once you get to this step and do the equating the cross products, then the math presents itself about whether you multiply or, in this case, we had to divide. So the math presents itself. So even for basic problems, I would highly advise trying to make this more of a systematic process. But what we're going to see on the next slide is some problems require lots more sophistication. All right, so let's look at this example right here. So we have 5m to in, okay? And you folks that are more familiar with units or learning units, these are called meters, these are inches. We've already seen that, right? All right, and so what we want to do is we want to convert 5 meters or 5 m's to in, okay? And so the thing is, we need our table first of all. So here's our table, all right? And we're trying to go from m's to in's, okay, or from meters to inches. You folks that are familiar with these units might be wondering why I keep doing that, but some people aren't that aware of them. Okay, so first of all, notice there's no m's over here. M's are actually a metric unit. So we have we have an m here, that's to cm. Keep that in mind, okay? Here we have an m, but that's to km. All right, and then there's nothing in here, so nothing in there will get us there. All right, here we have an m to yd, okay, like that, and then none of these have m's in them. So it looks like we have a problem here. There's nothing that has m's to in's, okay, like that. But there is some links, and that's the thing. Sometimes we have to piece things together to build up to where we're trying to get. All right, And so notice down here at the bottom we do have INs to centimeters or cm, okay? And see, that's an English to metric conversion, all right? And if we look over in the metric area, we do have a cm to m, or a centimeters to meter conversion. So if you think about the process, I could start with my meters and use this to convert it into centimeters, then take that number of centimeters and convert it into inches. And so sometimes we have to uh, link some of these conversions together, and we have to find a path for that. All right? And so what we can do here, if we think about that process, we can go from M to CM, get that answer, and then go from CM to IM. Or again, I know some of you are getting a little bothered by me saying that, but if you understand the units, we can go from meters to centimeters, then centimeters to inches. Okay, and so all we need is those conversion factors from that chart. Oops, sorry. And so looking here, to go from meters to centimeters, we would use this conversion factor right here. 1 meter is 100 centimeters. All right, and so we're given that 1 meter is equal to 100 centimeters. Okay, and then to do this second part, centimeters to inches, we would use this conversion right here. This conversion right here. This is really 2.54. I got this from one of my colleagues. I'm not exactly sure why she typed that 0 there. All right, and so I'll get that corrected when I distribute it to y'all. But it's actually exact. 1 inch is exactly 2.54 centimeters. Okay, so so that's the conversion factor. Oh no, I got disconnected here. Sorry, I'm not the best with this. So this is number 3. We're doing 5 meters to inches, and we saw that we can go from meters to centimeters, and then centimeters to inches. Okay, and there's our conversion factors is that 1 meter is equal to 100 centimeters, or m's and cm's, and then from that chart it tells us that 2.54 centimeters is 1 inch. And so what you do is you just take it one step at a time, all right, and don't rush the process. And so, oh, there's my old problem. Sorry about that. Things are a little wacky on this slide, aren't they? Okay, so let's just move those out of the way and forget about them. All right, so you just treat it as 2 problems in one. Okay, first thing we're going to do is convert these 5 meters into centimeters. Okay, and so remember I can, so here I have meters over centimeters. So this is step 1. Okay, so we have 1 over 100 is equal to, where do the 5 meters go? They're up here in the numerator. And so the 5 goes in the numerator, and then you could use C as your variable if you wanted to. That would help you. Okay, and so now when I equate the cross products, I have 1 times x is equal to x, and then 100 times 5 is equal to 500. Now you got to be really careful on these multi-step problems in terms of what this is. X is in the denominator, so that's another number of centimeters. Okay, now what you do is you just pretend like this was what you started with. The centimeters is what you started with, and so now we're on a step 2. Okay, and for step 2 we're going to use this second conversion factor right here, that 2.54 centimeters equals 1 inch. All right, and so for that one, those are going to be, in terms of my conversion factor, that's going to be centimeters over inches. Okay, like that. And the given one is 2.54 over 1, like that, is equal to, and then our 5, we're starting with this 500 centimeters, that's in the numerator. And so the 500 will go here, and then we're trying to find the part down, or we're trying to find the denominator, right? And I'll just call it x in this one. So now whenever we equate our cross products, our first cross product are these two, 2.54 times x is equal to 1 times 500. That's 500. Now to isolate x, I would divide by that 2.54. For my exact answer, this is the best I can do, 500 divided by 2.54. But now we can calculate that on our calculators, and so 500 divided by 2.54 is equal to, it comes out to be 196. I'm just writing down what I have from my calculator, 850394. But then I'm going to tell you to round to 2 decimal places. And so here's my second decimal place. I look to the right of it. That number is smaller than 5, so I'm not going to round here. And so I would say 196.85. What are we talking about here? Here's our x. We're going to inches. Or you could just look at the original problem. We were trying to go to inches. Okay? And so there would be that correct conversion. Okay, so I feel like this video is getting pretty long, so I'm going to go ahead and stop there. I hope it's enough. But just be aware of that, especially with problem 3 there. Sometimes you have to find links, and they're not always the same path. There's other conversions on that chart that we could have used to get to this answer. And so you just need to, on some problems, you need to find a link. And then the other thing I would say, like I said, I would advise practicing this and getting used to it. And hopefully in a later math class there ends up being a kind of a simplified version based off of this that kind of shortens up the process. But understanding this process helps you understand that much more. So I hope that helps. Let me know if you have questions, and all the best.